Okay, so now that we have our solution, I just would like to visualize it and actually compare it with the solution to the same problem using the classical find an element method that I happen to have, right? So like we saw, pred here, this object pred contains the diffnet solution, the NeuroSolver solution, and I have this file, this numpy file, fem.npy, which has the solution via find an element method. So I'm going to load this and plot these two at a particular slice in x equals, let's say 32. These are both 64 cubed data structures. I'm going to slice them both in the middle and show those two 2D images side by side and compute the error between them. So there we go. So on the left we have the diffnet result, in the middle the FEM. They're visually pretty much identical. It's hard to tell which one is which. And on the right hand side I have the error, the difference between these two images. And as you can see, the error is like orders of magnitude smaller than the amplitude of either, so showing that the agreement is in fact very good. And we can scan this, move this slice around along the x-axis to see how things change. So this is at x equals 20. Still, the results are pretty close. As you get closer to the edges, like x equals 0 or 63, the results start to diverge a little bit, so diffnet becomes less precise, but that's expected as a border effect. At 5, they're still pretty close. At 1, one can actually see, right, at 1 that the results don't quite match exactly. Diffnet is less precise than the find an element solution. But otherwise, these are all in very good agreement across the board. Okay, so the last thing to do is to shut down the server. We can send a get request to the server, sending the command stop, and it'll reply back saying it stopped. And now we're done. So this concludes this demo on how to run, using the inference server, run inference on a pre-trained diffnet model to solve the 3D Poisson equation using the NeuroSolver.